So this one is the video to help you do your calculations for the nuts. Okay, how many calories there are in a nut. And so make sure you write the nuts that you used. I'm just hypothetically using peanut and I'm just hypothetically using some data. This is not factual. This is not something that I've done in the lab. I'm just picking some data, okay? So anyhow, the data that you acquire in the lab, which means what is measured in the lab, is the one that I have typed. Okay, so this is the one that you've actually measured in the lab, which is the mass of the watch glass. Then the after combustion, that's something you've measured in the lab. Mass of the can and water you've measured, mass of the can you've measured, and the temperatures. Okay, you've measured all of this. The highlighted ones are actually the calculations, and that's what I'm going to show you. So some calculations, they're easy because it's just subtraction, and then the rest of it I'm going to show you how to do as well. So I'm just going to take this one set of data, and whatever nut you use, it's going to be the same calculation, right? Okay, so mass of the nut burnt, okay, that you have is, 33, which is the mass of the watch glass plus nut, and then after burning it, right? So that's going to be 33.425 minus 33.027. You have to show at least one set so that I know what you're doing. 398. You don't have to write units, although I don't know, I always like writing the units. So then the amount of water that you have will be, of course, minus the can, right? So 354 minus the 2.218, and the mass of the water then is 50.136. Remember, the mass of the water is the one that is getting all the energy. The can is not getting the energy. I mean, it is, and that's why this not the best kind of experiment, because your data is quite flawed because just the way the experiment is set up, but that's the nature. It doesn't matter. It shows you at least how the process works, right? So let's say 28 minus 25.1, that's your temperature change, which is then 3.2 degrees Celsius. Okay, so those are the numbers that you find out. And then once you have that, now we're going to move on to over here and then follow up with the calculations for each of the trials. So here we are using peanut. Oh, let's see how it comes out to be. I don't know. So your calculation for the first one, again, remember you're using the amount of water because that's where the energy went. So 50.136 grams times the temperature change was 3.2 degrees Celsius times the 4.184, which is the specific heat of water. Okay, joules per gram, degrees Celsius, and this gives us 671.26 joules. Okay, so that's what it is. And once you have this, then this is joules per gram. So then you divide this by the nut, okay, how much grams the nut was, and that's 0.398 grams. My writing is coming out a little bit big. I know yours will be a little smaller than this, so you can fit it in this box. And that's equal to then 1686.59 joules per gram. And that's how you will do the calculations then, okay? So you'll do the trial 1, trial 3. If you did that, you figure out the average from there, and the accepted energy, of course, average energy, accepted energy, you'll find out, which I think is 249.00. So 24,900. Oh my God, how much did I get? Oh, 1686. Oh, that's terrible. I think that's let me just check one thing really quick. 671.26 times, no, divided by. So 671.26 divided by 0.398. I'm making sure that my decimal is in this right place. It is in the right place because my God, that looks really awful. So the percent difference is going to be 1686.59 minus 24,900 divided by 24,900 times 100%. And oh my Lord, that's 93% less, So I got very, very, very horrible data, okay, with all of this. But anyhow, that's how you will do the calculation for the nut experiment. Okay, so again, I don't think you're going to get the best kind of data for this, but just learn the calculations. Okay, all right.